Hi, everyone. Thanks for joining. Um, so I'll be talking today about serverless security testing or automated serverless security testing and how to make sure your serverless development is going or moving into production secured without delay and without friction. So my name is Tal. Um, I'm right now I'm a senior director at Contrast Security, leading the serverless and cloud native development in the Israeli Innovation Center. Previous to that, I was CTO and co-founder at Cloud Essence, got acquired by Contrast about a year ago, and before that, I headed the security research at Protego Labs, got acquired by Checkpoint. So this is why I'm coming from a serverless background. Those two startups were doing serverless security. So before it was serverless runtime protection, and then I decided to take it shift left and bring it into the development lifecycle. Uh, that's it. You can reach me at any of these social media channels. So Forrester says that by the end of the year, 25% of all developers will use serverless regularly. That means that one of four, I hope that for you, the audience, you're already starting or using serverless. I think it's amazing. It really lets you uh, focus on what matters. Okay, so the cloud native transformation in general is something that already started. We've been hearing about cloud native containers, serverless in the past couple of years. A few companies that are leading or pioneering this, like iRobot and Skyscanner. But even if we're moving back to the bigger or heavier companies like AT&T, Mastercard, Coca-Cola, etc., they already decided to move and started the transformation into cloud native, even though that right now they're probably uh, working in a hybrid solution while having the legacy application as a monolith. They start developing new applications or new versions of the application in cloud native. So we're going to see everyone or most of the companies moving towards the fully cloud native environment. This is uh, according to almost every prediction. But what is cloud native development or serverless development to that matter? So it's different in several ways. The first one is the architecture. The architecture is different. It's less of a synchronous monolith application with one big flow. It's an event-driven architecture who takes multiple dozens and thousands and even 10,000 of different resources and just connects them with some configuration and some flows that creates this big logic of application. But we'll talk later about what are the challenges when you're doing it. The cycles are different, less waterfall, more agile, super agile, hyper agile, whatever you want to call it. DevOps operation, DevSecOps, you probably heard of it. Short cycles, short experiments. You can push value into production on a daily basis, basically. The processes are as well different. They're most around automation. If you don't have automation, it's really hard to control your cloud development. If you're traditionally you were looking at a server update where everyone is crossing finger for the new version coming up and their maintenance time, it's not like this anymore. Production production is shipped. Code is shipped to production every day, every minute without stopping, and it can coexist with the current versions at the same time. So you don't have to stop, test, maintenance. You're really just pushing more and more value into production. The decision makers are also changing a little bit. It's less about top down, not the engineering manager takes the decision to push something, but more responsibility is given to the developers themselves to push into production, to take decisions, to take responsibility. Even security in some cases is in the the responsibility of the developer when pushing new code. Serverless architecture. This is a picture of a relatively small application, I would say. Some kind of a graph of flows and connections that we created. So if you look at it like this, you have to understand that each of those resources that you see on the screen is a single standalone component, completely standalone, and you have to take care of it by itself. So you have to take care of the access control, zero trust, or whatever, the authentication, the input validation, and all the security aspects on each of those components. Yes, sometimes you can say, okay, whatever comes from trusted zone, maybe, or a trusted resource, I will take the risk. But you still have to understand where are your entry points, what are your perimeters. And as we will see during this talk, you'll see that it's a little bit different than what we were used to. So think about it. When we're approaching security teams that their organization talks about, develops on serverless, develop serverless applications, they don't really, they can tell you, we have 300 Lambda functions or around that numbers, a couple of APIs, 3 databases, etc. But they don't really understand what is connected to what. And this is not something that you can really see unless you have the entire context of the cloud and you're able to make the connections. So this is a good visibility of what serverless application looks like and what are the challenges are. Okay, so serverless is mostly an event-driven architecture. Again, less of a synchronous request response type of application. Yeah, there might be an API that expects request and response synchronously, but it's not what it's about. What happens is that an event happens in the cloud, and the event can be a log, an IoT rule, a Dynamo, or a database entry change, a file upload to a bucket, or a file download or delete, or an API call. It could be a code commit or any other event that you can think about that is configured to run a function. This function, in this case, we will mostly talk about AWS, around AWS, because it's the most common one. So in this case, your code, your application is running this code, right? So everything else is taken care or is given as a service by the cloud provider. All you have to do is write your code and make those arrows. And by arrows, I mean set the configuration. What is my event to start running my code? And when the code executes or runs, what other services am I connecting to? So what happens is that the event happens, the cloud provider spins up an environment for you. It's some kind of a closed container, so you cannot really SSH to it. It's a given environment with your code inside. The code runs, and when it's finished to run, then the environment is shut down. So you don't have any access other than the code itself that runs. But beware, because when we're talking about code, we're still talking about application security. So your code could lead to your mistakes and some big cloud disasters. We'll talk about that. All right, so if we're taking the AWS Lambda environment and we'll try to understand some of the security aspects of it, we can think about a few things. First of all, the environment is a read-only environment. So all the things inside, except from the /temp directory, is given to you by the environment, and it's a read-only. So, for example, information like the code resides inside. Information about the keys, the keys that gives the Lambda, the function, the environment, access to talk with other services in the cloud, also reside inside. But other things usually less matter. So if we're used to the POC that we're running on servers to see if we can steal sensitive file, then the first file we'll try to reach is etc password, right? That file doesn't have any meaning in your environment because it's a it's a closed environment, so you don't have SSH to it, you don't have any other services running in it. The environment, as I said, is not wired to the internet, so you cannot SSH to it. Yes, you can make HTTP calls from within outside, but you cannot really access the runtime itself other than running the code. And the data is temporary. So when the environment or the code finished to run, the environment shuts down and the data that was under /temp is gone. And I've put those stars next to it because it's not really gone. The environment, for performance reasons, the cloud provider will keep your environment alive for next events. So in order to avoid what is called cold start, where the environment runs for the first time and it takes a few seconds to spin it to make it ready. So there is a reuse of environment. And that means that for the security aspect of it, that means that if your environment runs once and writes data into the /temp directory, and then another request coming in to execute the code again, you might end up running on the same environment with the previous execution's data or one of the previous execution data inside. Why is it important? Well, first, you cannot rely on this. So you cannot really say, hey, I want to continue to process the data on the next execution because you don't know which environment you'll be living in. So you cannot assume that. But for security reasons, if the data is there and someone has access to the environment because of some of the problems that we'll discuss today, then you might end up with leakage of sensitive data. So you probably want to take care of that. Okay, so we talked about a little bit about serverless, but serverless security, is that a thing? So we can see a continuous increase. Yeah, this is quite old, but you can see a continuous increase of serverless computing trends on Google. This is Google Trends. And in the past 5 years, there is more and more discussion around serverless. It becomes more and more mainstream. As I said, a quarter of the developers should be using serverless by the end of the year. But where you search about serverless security, it seems like no one really think about it. I assume this is an extreme, but it says until July 2019, there was no more than maybe a 1 or 2 at the maximum searching serverless security. So I need to develop serverless applications right now. If I'm the developer, the first thing I would want to see, well, maybe not the first thing, but one of the first top 3 things I would search for in Google is, well, one was how to do that. Second, security. But we know that it's not the case with everyone. And as you can see, not enough people talk about it, or at least look for information about it. And I'm pretty sure this one is me throughout the entire time when I started working on that. Okay, maybe it's not a thing. Maybe serverless security is not a thing, and we can just apply traditional application or traditional AppSec to serverless. Would that work? Well, from experience, it would slightly work. Not really. I mean, not something that you can scale, not something that you can rely on when you developing serverless within your organization. Yeah, if you have some experience in application security, you might take some and apply some changes to your own, but it's not something that you can just plug and play. And let's talk about it. So first, let's try to understand some of the changes in the landscape, the security landscape of the application or the serverless application. So here what I have is a screenshot of a very simple Lambda function with just a few, maybe less 30 lines of code. There are some minimized collapsed here, but basically this is a very simple Lambda function that receives an event. The event is based on a Dynamo or the database changes. And what it does is that it connects to a DynamoDB, which is a NoSQL database given service serverless service given by AWS, access the orders table, and then puts one item inside the table. So it's like writing an entry into the table. Then response. So maybe it's just an HTTP. Anyway, what is important here is that in order for this code to execute, to work, not for security, to work, that means the developer needs to configure the access control, or IAM, right? In identity and access management, for the function inside the cloud, the environment, inside the cloud ecosystem. That's by itself is a problem. Not in this specific case, this would be easy, just one API call. So probably API SDK or API call, whatever you want to call it. But the problem is that in AWS, there are more than 7,000 different actions that you can choose from. I think that by now it's probably even closer to 10K. That means that the developer at the time of writing the code needs to understand what is the permission that it needs to give to each of the functions. Yes. So what happens usually, and this is from experience, is one of two things. Three things. One is the developer is security oriented. He's not developing mass serverless application. He has time and he's aware of security. Then he does security reviews or makes sure he understands what the function actually needs, and then tries to create maybe a trial and error until it works. The next thing that happens is that the developer goes to the documentation of this service. And the third thing is very common, is that the organizations say, we're developing a lot of AWS Lambda functions. We cannot really wait for each developer to investigate. So what we're going to do, and we cannot trust them for security. So what we're going to do is that we're going to create certain roles inside the cloud environment. Each has a certain purpose access level, and the developer will choose one of those, the best one, maybe, or the one that works would probably end up being that fits the function. So what happens, or what ends up being, is that the developer will probably use some kind of a stars and wildcards, which basically mean admin access. That means in this case, as you can see, the function has the DynamoDB star action permission. That means that the function itself can perform any action inside this service. That means creating databases, deleting databases, not talking about entries, reading, writing, modifying access entries from the database, and much more, changing permissions, changing backups, anything that you can think about. Not only that, it can also do that with a star here on any table that is configured inside the cloud. Configure or not configure, because they can actually create tables. So basically, this function is an admin of the DynamoDB service. What should have been done is that the developer should understand that put item is translates to, put item, which is the action. This is a Python code. This is the AWS transform or syntax for the permission for this action. And the table itself should be specific to the table, to the orders table, which in this case can be found in the environment variable. When doing those two things, giving those two permissions, setting those two permissions inside the function, we're really limiting the ability of the function inside the cloud, the impact or the blast radius. That means that even if the function is hacked in a broad sense of it, someone has access to the runtime, someone can even change the code itself in runtime or execute arbitrary code. It can only create one entry at a time on this specific database. Not that it's not bad, but it's much better than having the entire service given to you as an admin. And this is easy when you're looking at 20 lines of code on one functions. But what happens when you have thousands or having tens or dozens a day, and I have a customer who claims to have 3 million functions. This cannot scale, of course. All right, so let's see a demo about why is it a problem. So I have a Slack channel here, and there is a chat bot in the background that works with a Lambda function behind it, and the Lambda function is vulnerable. It doesn't really matter. It just uses some kind of a CVE that is vulnerable to code execution. So this is a function, and it has the star access to the database, and the function has a CVE that it allows me or allows the attacker to run arbitrary code with those serialization, JSON serialization. So after investigating, I crafted this command who creates, so I can write arbitrary code to the function. So I can just create a new client and do a scan. Scan is the translation for reading the entire database. And I can give the permissions, the parameters of the DynamoDB table from the environment variable. I don't even need to know it. It's not really, it doesn't really matter here, but as you can see, I was able to extract the entire database into my Slack channel. Right, there is a vulnerability in the code. What I'm going to do now is I'm going to change the permission of this function. So I'm going to change it from a DynamoDB star to a DynamoDB put item, like we've seen in the code samples just a slide ago. Now I've saved the change, the configuration. As you can see, now it's just limited to put item. And now I'm going to run the same, execute the same attack as before, the same payload as before. And you'll see that nothing happens because the function is blocked by the cloud provider itself. The function will try to write, to do a scan to read the data, and will be blocked by AWS. Okay. Another issue that we have in security is the loss of perimeter. On a monolith application, we're used to synchronous type of events coming in through the load balancer or through the API gateway, or an API. It doesn't really matter, but there is a request coming in and that waits for a response back. And you can put all your security arsenal tools on that spot, right on the perimeter. It can be data leak, so DLPs outside, firewalls inside, whatever you wanted to in between, monitoring, etc. But we're looking at serverless applications. It's a little bit different because the perimeter can be anything inside the cloud, and the cause to trigger your code can be analytic processing, and we discussed this, file uploads, APIs, of course, database changes, logs changing, etc. Can be really anything that you can do, you can think about in the cloud. And that means that you cannot really control the entry point. It's actually not given to you until it reaches the code. So you cannot say if someone sends, if someone changes the database, I want the data to go through some kind of a tooling, some kind of a processing before it reaches my code. No, if someone changed the database, your code will start running and you'll have to take care of it. Actually, I want to postpone the demo to a later stage. All right, so we've talked about a few security risks. There are some other security risks. Event injection, I'm just going to enumerate some of them. We'll discuss this a little bit more in the 20 more next minutes that we have. So event injection is the equivalent for injection attacks. We call it event injection because an event is what triggers your code. So it can be or event data injection or whatever you want to call it. Someone uploads a file, but in this case there is some malicious input that will reach into your function. So you have to take care of that. Broken authentication. Uh, I'd say this is two types of things together. One is authentication of your functions. The functions are ephemeral and stateless. That means that there is no flow authentication that you can create. There is no session or anything. If you want to keep a session or an authentication, you have to do it out of bounds. So you can save a state inside a database, of course, but it will probably not serve your serverless application well. So you have to take care of your of everything that reaches the function, or you have to understand that there is zero trust in your code. But it can also be an authentication in other services like API gateway or S3 bucket, which can be accessible without any authentication, which could really be an issue. Sensitive data exposure is generic, but in your cloud, of course, there are many sensitive information. If we're talking specifically about the functions, so we talked about the keys that we can steal from the environment and the code that we can steal from the environment, and there are some other sensitive information which you want to protect. Overprivileged function, we've discussed this a lot. This is maybe one of the most challenging things when dealing with serverless functions. Vulnerable dependencies, this is not new, right? Actually very common today. I'd say even too common in most cases. So functions are usually smaller in terms of how much code they will contain. Could be something from 30 lines of code to 500 lines of code, maybe more, but usually not too much. But in order for that short, maybe 50 lines of code to work, they have to bring a lot of dependencies. And that means that, of course, CVEs will land into your Lambda functions. Insufficient logging and monitoring, if we're taking the traditional web application, let's say, so you have to implement your own logging and monitoring mechanisms. Here is a little bit different because the cloud gives you this information raw. You have to know how to deal with it, how to process it, and how to collect it. So, for example, you don't have an access file, so your network entry access file, but you can collect this from different type of services in your cloud, your CloudTrail, or if you want the functions output, you will have to connect to your CloudWatch logs and pull out this information. But it's very hard to understand what you need in terms of security. Open resources, this is maybe another type of a broken authentication, but externally to Lambda functions. So resources like S3 bucket, which are accessible. I'm not sure if you're aware of, but there are, if you know Shodan for IoT devices where you can just log in, search for a camera and look at someone's garage, or maybe even worse, then there are websites that monitor cloud storage that are publicly open. I think it's called Gray Hat Warfare or something like this, where you can just log in and find passports because someone forgot his bucket open. So could be also APIs, API gateways, SNS, so notification service that are open, and some other services, which is a very big issue. Denial of wallet versus denial of service. So Lambda as a service, Lambda has 1,000 concurrent execution, which you can allocate for specific functions or for the entire service. So let's say you have 1,000 requests at the same millisecond. That means that your next request, if there is 1,001, will execute or will exceed the limit and will not receive the response that you're getting. So that could be a denial of service if someone really kind of a DDoSing you. On the other hand, if you're saying, yeah, let me not, instead of limiting the resources, let me have whatever, as many as possible, then you're actually paying for it. So you cannot, if someone actually just continuously triggering your functions, if it reaches your functions, somehow there is an API, but the API is unauthenticated or is publicly authenticated, so it's like a e-com or something where everyone can log in. Someone can just continuously shoot API calls 24/7, and you will pay for it. Yeah, you will pay a couple of cents for the millions, but if it's a distributed attack, then maybe you'll have some additional payments. And the last thing that I'm touching here in this list is insecure shared space, which we talked about, the /tam directory, which is actually shared between different type of different executions. Oh, right. And secret management, which you have to take care of, because if you want to put sensitive information in your function or in your code, then you're probably going to do it in by default or hard coded. I hope not, or in the environment variables. And you need to understand that there are risks, and you might want to encrypt those. So, can security scale in serverless or traditional security? There are, let's try to understand. So there are a lot of services. We've just touched a few. I think AWS has around 200 types of services. Uh, there are frequent developments. It's hard to understand what is connected to what unless you're the developer that wrote that specific connection. You're asking the security team? I don't think so. There are many developers with less AppSec. It was true before, but now there are uh, more frequent production, pushing into production. So the development cycles are faster, which makes it even harder for the security team to scale. Uh, and it's hard to understand what is important. Not every function is important. If you have 5,000 functions, you have to understand which ones are at risk, which ones are connected to an API, which is not private, and maybe is not in a VPC, and maybe it has lower authentication or is public facing. So it's really hard to understand those things. It's not one server that you can say this server receives some APIs and talks to this database. So you know this server is or is not at risk, or at least has sensitive information. In this case, each function is different. So we're not sure if the security is really the same, and this is what we'll try to cover in the next 10 minutes. And when we talk about serverless, it's not just about code, it's also about configuration. So it's kind of a challenge to know who's taking care of the security in some cases. Is it the DevOps? Is it the engineering? Or is it the security teams? And we've seen different organizations, and each has their own type of arrangements. So traditional testing in modern CI/CD pipelines will probably look like this. We have Mario, the developer, on the other hand, who wants to test throughout the pipeline. So we'll use SAST probably, or an SCA on his code, but that means a lot of filtering and a lot of working through false positives. Yeah, we've got 100 or 1,000 CVEs, but we're not really using those. So they move into an IS solution, but that means that they need to have a coverage to understand what they're testing, and it's not sure it's going to work. We'll talk about that in a second. And also probably needs a lot of help from the security team. And if they want that really hard to do in the pipeline. It involves a lot of configuration and a lot of prioritization and understanding. Hey, there is a new API, what I'm going to test. But there are some other problems. And the problems is that these tools don't really understand the cloud. And they don't understand the cloud because there is a lot of context in the cloud that they cannot configure or they cannot understand because they're coming with a different mindset. For example, they cannot see, if you're looking at past, for example, or scanners or fuzzers, they cannot see anything that doesn't have a URL. And they don't have a sink and a source. If it's a SaaS in many cases, all of these is really hard to scale and makes it really, it actually blocks the developer. So what ends up happening is that developers usually not going to take or use those traditional tools into serverless, and if they do, they're going to do a lot of work to make it work a little. So let's see how security testing works on serverless application. This is a sample iRobot, uh, really just one service of their configuration with their system, the iRobot Roomba. This is taken from the Amazon website. There's an iRobot Roomba who transmit an API call, which runs a function that then runs to a queue and does something with IoT, and then the queue calls another function and another function, and those writing into a log. And there are some IoT rules and policies and registries in behind the scene. Uh, okay, let's see how that. So how I'm going to test this. So the first thing that comes to mind is maybe the easiest one. Let's say just let's do the check, right? We can run an SCA or email scanning if that applies. That covers maybe 10% of your application. Yeah, it might fix or identify problems that you imported from different libraries, but it's not your code. In many cases, it's not related to your services and your cloud configuration. And all of these are the most important parts in your application. So you're actually not really scanning, you're just doing some checks. Most of the cloud providers themselves gives those solution as a default because it's really easy to do so. So the next thing that we're going to do, we're shift left organization. Uh, so let's do infrastructure as code security, which is great. The problem is that, again, you have zero code coverage because infrastructure as code just looks at your configuration. It has limited visibility. It's dependent on the infrastructure that you're working on, if it's Terraform, Serverless Framework, Pulumi, or any other. It has zero logic or prioritization. It just knows lines, hard-coded lines, which are configured. So if it can find a bucket that was not configured, it will let you know, which is great, by the way. But it's, again, zero code coverage. So let's run an IAST, right? IAST is maybe to-date, modern. AppSec is maybe the most accurate and reliable security tool. But it has its own limitations. Even though it really allows DevOps and DevSecOps operation, serverless doesn't have servers to instrument, right? So you cannot take an agent and put it and just instrument it into your function. That means that you cannot really test or run IAST on your function. So let's do SAST, and I bet most of you do. The problem with SAST on security or serverless is that it sees each resource as a separate entity. And in many cases, that's not the case. Your code doesn't start and end in those 50 lines of code. It just started a chain reaction inside your cloud. There is a HTTP request, and this Roomba probably doesn't even want a response. Maybe, yeah, 200, okay, don't try again. But there is nothing that you can really understand here. Oh, sorry. From that. So you're looking at this, and then you're looking at those functions, but you don't really understand what your source and what your sink, because this is one application, and you cannot scan it as one application because there is some services in the middle that connects those flows not by code. So the tools cannot understand those. So let's run a dust. Last resort. The problem is that if you don't have a URL, if you have a URL, there is nothing to test, right? You can give it an endpoint or a URL through this API, and you will send requests, and you will either get 200 OK, 403, or 500. But you don't know what's going on inside your application. If this goes into the queue to the database, processed by another service, those are not coming back to the API. So really, all you can test is one API in this case. And I've seen it happening with, of course, more complex applications. But there is a solution because we're dealing with the cloud. We can actually do things differently. So what we suggest is something a little bit different, but you have to think about it in a different way. You can connect to the monitored cloud just by a few clicks. This is given to you by the application. Of course, you have to write to bring up your cloud code into it, but it can be configurable with just a few clicks. And then you can, or what you need to do is understand the context. So discover all the resources, all the functions, all the policies, the configuration, the services that within this cloud, and try to connect all the dots, find the attack surfaces, the flows, and then scan those specific issues. But the best thing is that you're inside the cloud, whether it's an API call or you're actually inside the cloud, so you can really understand what's going on in there. You're not just looking from the outside, you're inside. So you can know if something happened and you can monitor continuously. So you don't really have to wait for the security teams to wake up and run their Q test or the new version test. You can just monitor the environment continuously and run scans automatically on every time that something changes in your code. This is an example. So Mario, again, the developer, decided to create a new API that runs a code inside a function that writes to a storage that triggers another function that sends an email to the user. The idea is that when this API is created, there is an alert. And this alert is getting into the system, and the system can then try to understand, connect all those dots in your cloud and understand those flows. And then you can test or do some security testing, whether it's static, dynamic, or both. In our case, to understand, to find problems inside those flows. And then you can actually interact with those services to understand if there was an issue with any of them. And if there was, not only you found the issue, but you also know the impact, because this resource will give you the information of what you can do inside your cloud. So you can say, hey, if this function is vulnerable to a command injection, then this table is at risk. And at risk because this function allows anyone inside to write data into it or to read data. And you can do that even things without APIs. I showed 2 years ago in Black Hat Europe how I managed to steal data from the database with my voice through an Alexa device. I was just saying things to an Alexa Echo Dot that was running vulnerable code behind. And with my own voice, I was able to steal information. So you're not able to scan this with other tools, but you can understand that with a purpose-built solution. So in our case, what we're doing is we're scanning the code, we're scanning the context, the configuration, the cloud, and then we can actually generate, if that was the original policy of the function, a specific policy for the function with just this action. And of course, it's nice when it's one function, but when you have thousands or tens of thousands or millions, this is not something that you can do manually, and you have to scale. And again, we talked about the vulnerable applications for AppSec, for vulnerable custom code, so we can identify those as well. Before I'll show you the last demo, I want to share with you there are two interesting projects in serverless if you're interested. One is the OWASP Serverless Top 10 project. Again, open source OWASP, of course. There is an open call to collect information. Right now, it's just a translation of the original top 10, even the last version. But we're working to create a serverless tailored top 10 that will hopefully guide everyone in serverless into a more secure environment. The next project is the DVSA, is a damn vulnerable serverless application. Again, under OWASP application that I created. There are some other contributors as well. This is a fully serverless application which you can install. You don't have to do anything. You have to have an AWS account with permissions, and then you just click and it installs everything. And you can go into the GitHub project to understand all the problems and some documentation. Just beware, please do not install this on any AWS account or any production account that have sensitive information, because you'll be deploying services with that are vulnerable and have multiple excessive permissions. So some other people can maybe find those and get those sensitive information out of your application. So let me just end up with the last demo, and then we're into the Q&A. Oh, sorry. So there is a email service. So what I'm trying to show you here is that you can run vulnerable code or execute code with Lambda functions behind email service. So you don't really have to have an API per se here. So I've sent an email to a call for papers, and I got an email back saying that they received our submission, and that we'll get back an information. Now I'm going to attach a malware. So basically a PDF with some malware instead. So what I'm going to see now is that I got a response. The response said that the file was found malicious. And if I click on the review, I'll see the response from VirusTotal about my submission. All right, so it failed. But I can understand that there is some code running behind the scene on my upload. So now I created a specific exploit. This exploit is basically an AWS code, right? A Python Lambda code that sends an email or creates an SES service, sends an email to some participants that I'm trying to target, and then this is the first part, is some kind of a phishing attack. And the last part, the second part here, is what I'm going to do is I'm going to change the permission of the bucket that holds all the submission to public. So it was secured before, and I'll show you. It is secured now at this point. But when I'll exploit the function, I'll make everything public. So I'm just uploading it to, okay, so I'm wrapping it into a tar.exe file, and then I'm going to upload it to an S3 bucket owned by me, by the attacker. So then from the function, I can pull the code inside the function and execute it. So now I'm going to show you, I have an Ngrok service here with an HTTP tunnel, so I can get requests or information back to my computer. I created this payload inside the file name with a curl to my own host to download this tar file, and then unarchive it and then execute it. So this is the bucket. Sorry, this is a submission bucket where all the submissions are hosted, and you can see it's access denied. Now I'm going to do the same attack, send the same submission, only this time with a malicious file here. The malicious file name that I created. And then when I send it, there is a vulnerable Lambda behind that will send me some information here to see that things are happening in the background. So phishing email sent and bucket hijack. So this is a phishing email that I created from the domain of the host, because it's coming from their service or AWS account. Congratulations, you've been selected, accepted. Click here, phishing site, to collect your reward. Okay, that was cute, but the most important thing is that, okay, thank you also. But the nicest thing is that now I change this bucket to a public bucket, and all the information inside is now open to the crowd. So this is an attack that takes advantage of a Lambda function that is running behind an SES service, the email service. That's it. Thank you for attending this talk. If there are questions, I'll be happy to answer.